Hello children, welcome back to my channel. Now I am dealing with 10th class maths probability exercise 3.1. In that the first question is complete the following statements. So let us see this. First one, probability of an event plus probability of not an event, that is P of E plus P of E dash, that is nothing but 1. And probability of an event that cannot happen is, probability of event that cannot happen means there is no chance of getting it, that particular item is not present in the given data, that is 0. So such an event is called as impossible event. It is not possible. Impossible event. Probability of event that is certain to happen. Definitely it will happen. Its probability value is 1. Such an event is called as certain or sure event. That is named as certain or sure event. Sum of probabilities of all elementary events of an experiment, it should be equal to 1. All the probabilities, if you add, you will be getting 1. Probability of an event is greater than or equal to. See, it lies between 0 and 1, we have discussed. Greater than or equal to 0, less than or equal to 1. So, these are the answers for the first bit, children. Please note it down. Now, children, second problem. Which of the following have equally likely outcomes? Explain. Why are they? If you say equally, why? If you say not equally, why? So, first one, a driver to start a car. Driver has to start a car. The car starts or does not start. See, there are only two chances. Either it starts or it does not start. So, it is equally likely outcome. Why is it? Because the chances are equal. You have got equal chances. It may start or it may not start. Okay. Now the second one, a player attempts to shoot a basketball. He is trying to shoot it. She or he shoots or misses the shot. Whether she can or he can shoot it or misses the shot. See, here also the probability is equal. Chances are equal. So it is equally likely outcome because the chances are equal. Same answer. Chances are equal because the problem given is like that. Next one. A trial is made to answer a true or false question. Answer is right or wrong. Same as it is. Either the answer will be right or wrong. There is no other third go. So it is also equally likely outcome because the chances are equal. So it is also equally likely outcome. Next, fourth one. What is fourth one? A baby is born. It is a boy or girl. Of course, here also same chances are equal. So it is also equally likely outcome because the chances are equal. So In all the cases, you have got equally likely outcomes, children, because the chances are equal. Already, when I was dealing with the do this sums, I have divided the board into two equally likely outcomes example, not equally likely outcomes examples I have given. In that, I have explained you equally likely outcomes will have same chances. Not equally likely outcomes will not have same chances. That you should understand, children. Note it down. Now, third question, children. If probability of event is 0.05, what is the probability of not E? We know that probability of event plus probability of not events means PE bar is equal to 1. Probability of event is 0.01 plus probability of not event is equal to 1. Therefore, probability of not event is equal to 1 minus 0.05. So, how much, children? 1. 0.05 means 0.00, you have to keep it here. So, 5 here, 9 here, 0.95. Therefore, probability of not E is equal to 0.95 is the answer for this problem, children. So once again, they have given probability of event. They are asking probability of not E. Not E means this is the formula that I have in the introduction class I have given to you, children. Probability of event plus probability of not event is 1. So probability of event is 0.05 plus probability of not event is 1. So probability of not event is 1 minus 0.01, that is 0.95 is the answer for this problem, children. Note it down. Now, fourth problem, children, it is like this. A bag contains 11 lemon flavored candles only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy or a lemon flavored candy? So, first bit is an orange flavored candy. An orange flavored candy means number of possible outcomes will be here. Orange flavored candy means let me write it as favorable outcomes. Possible outcomes we need not write here. Number of favorable outcomes. Number of favorable outcomes will be 0. Why? It is because the are candies. The candies are only lemon flavored. So, since the candies are only lemon flavored, there is no chance, it is number of, there is no chance of getting orange colored flavored candies. Therefore, probability of event will be equal to 0. That means orange flavored candies cannot be obtained. Next, she cannot take orange flavored candies. Next, A, lemon flavored candies. A lemon flavored candies. Lemon flavored single one, no? So it is candy only. So here also orange flavored candy. Here also the okay, all the candies here we get. Candies are lemon flavored. And now here lemon flavored candies they want means there is a chance number of favorable outcomes will be equal to 1. Why? Because all the candies are lemon flavored only. So she wanted to take only lemon flavored candy, so it is 1. Therefore, P of E is equal to 1. Okay, why did you write it here? Because you can write it here because all the candies are lemon flavored. Why did you keep it 1? Because all the candies are lemon flavored. So P of E is equal to 1. So let me explain once again, children. A bag contains lemon flavored candies only. Then what is the probability that a person takes an orange? The name Malini, she takes an orange flavored candy. So number of favorable outcomes will be 0. What is the reason? Because the candies are only lemon flavored. So if there is no orange flavor, there is no question of taking orange flavor. So probability of event is 0. Now lemon flavored candy. Lemon flavored candy means number of favorable outcomes will be 1. Why? Because all the candies are lemon flavored. So she can take it. So any candy she takes, that is lemon only. So probability of event is 1. Please note it down. Now, fifth problem, children. Rahim removes all the hearts from the cards. What is the probability of getting an ace from the remaining pack, getting diamonds, getting a heart from that is not getting a heart? So, children, this is getting a card that is not heart, getting a card that is not heart, and getting the ace of all hearts. So first let us see the number of cards. Number of cards will be 52. You know that, children, already I have explained in the previous video. Total number of cards 13 into 4. 52 cards are there. Then number removed. How many numbers they have removed? All hearts are removed. Hearts are 13. Each one, each color, each particular shape is 13 cards. Diamond 13, heart 13, spade 13, club 13. So all hearts are removed means 13 removed. So number remained. How many are remained? This is if you subtract, you are getting 9 here and 3 here. 39 cards are remaining. So number of possible outcomes is equal to 39. Now with this we are going to talk about each one. First one, getting an ace from the remaining pack. This is the first question, getting an ace from the remaining pack. So here, what is sample space here? Sample space is how many aces are there now? You have diamond ace and you have got heart is removed. So we have got spade ace and you have got club ace. This is sample space. That means n of s is equal to how many? 1, 2, 3. Okay. So probability now probability of event n of s is equal to 3 means what? Number of favorable outcomes. Number of favorable outcomes are 3. So what is P of E? Number of favorable outcomes by number of possible outcomes. Possible outcomes are 39. 3 ones are 3 ones are 3 threes are 1 by 13 is the answer for the first bit. And what is the second bit? Getting diamonds. Getting diamonds will be, here the sample space will be all diamonds. All diamond cards. How many children? Therefore, n of s will be equal to 13. That means number of favorable outcomes is equal to 13. Therefore, probability of this event is nothing but 13 by 39. 13 by 39. Ones are 13, threes are, you are getting its value is 1 by 3. That is the answer, children. Please note it down. I don't have space to do the third and fourth bit. I need space. Here, once let me explain you. Rahim removes all hearts from the cards. What is the probability of getting an ace from the remaining pack, getting diamonds, and getting a card that is not heart, and getting the ace of hearts? So first, what I have done, I have taken the total number of cards are 52. Number removed is 13 because all hearts are 13. So 13 when he removed. So what is the number remained? 39. So possible outcomes are 39 only. So getting an ace from the remaining pack is, so aces from the remaining pack means you have a diamond ace, you have a spade ace, you have a calaver ace. So sample space is this. So n of s is 3. So number of favorable outcomes are 3. So P of E, probability of event is number of favorable outcomes by number of possible outcomes, 3 by 13. That is 1 by 30. 3 by 39, 1 by 13. Next, getting diamonds. Getting diamonds, sample space is all diamonds. Diamonds are how many? 13. So n of s is 13. So number of favorable outcomes will be 13. P of E is 13 by 39. 13 threes are 39. 1 by 3 is the answer, children. Note down these two. I'll teach you the third bit. Third bit, children. Third bit is getting a card. Getting a card that is not heart. That is not heart means, children, this is the one. Removed one, it is there. So n of s becomes how many? 39 only. Why? Because without heart, see, these removed 13 are hearts. Hearts are removed. From the pack, 13 hearts are removed. So that is not heart means all this you will be getting. Therefore, number of favorable outcomes is equal to 39. So what is P of E? P of E is equal to number of favorable outcomes by number of possible outcomes. So how many are there? Favorable outcomes are 39. Possible outcomes are 39. This is nothing but 1. This is the answer for this third bit, children. Now fourth bit, getting an ace of hearts. Getting an ace of hearts. So for this, children, all the hearts are removed. Then where is the possibility of getting an ace of heart? all the hearts are removed. All the hearts are removed. Therefore, number of favorable outcomes is equal to 0. Therefore, P of E is equal to 0 by 39, that is equal to 0. This is the answer for the fourth bit, children. So, let me explain you once again here. Getting a card that is not heart. That is not heart means hearts 13 are removed. So, what did you get out of 52? 13 are removed means 39 are there. So n of s will be 39. Sample space will be 39. That means the number of favorable outcomes are 39. So probability of the event that is getting cards, the getting cards that are not hot is number of favorable outcomes by number of possible outcomes. 39 by 39, that is 1 is the answer. Fourth bit, getting an ace from the heart. Ace from the heart. See, actually, all the hearts are removed. Here we have removed all the hearts from the problem. So, number of favorable events, there is nothing, no heart, that is 0. So, probability of getting hearts is 0. So, 0 is the answer, children. I hope I am clear. Please note it down. Now, sixth problem is in this way, children. In a group of it is given that in a group of 3 students, probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have same birthday? What is that they have given? Probability of having, what is that? They said having same but not having same birthday. Okay, it is not having same birthday. Probability of not having same birthday. Not having same birthday is equal to 0.992. That means what? Probability of an event is 0.992. Now the question is probability of having the same birthday. Having the same birthday is how much? That means not having and having. That means it is P E dash is equal to how much is the question. We know that probability of an event plus probability of not an event is equal to 1. 0.992 plus probability of not an event is 1. Therefore, probability of not an event is 1 minus 0.992. So how much? 0.1 minus 0.992. So take 3 zeros here. So here 8, here 0, here 0, here 0. So 0.008. So probability of having same birthday is equal to 0.008. This is the answer, children. So the question is, there are 2 persons in a group who are not having same birthday. The probability of not having same birthday is 0.992. That means probability of the event is 0.992. Probability of having same birthday. See, it is not having, it is having the same birthday they are asking. If this is considered as P of E, this will be P of E dash because for the same 2 students they are asking. So these two are equal. This will be probability of event means this becomes probability of not event. And we know that probability of event plus probability of not an event is 1. So I have substituted the value of probability of event 0.992 plus probability of not E is 1. So what is probability of not E? 1 minus 992, 0.992. So I have got 0.008 is the answer, children. Please note it down. Now, seventh problem, children. Seventh problem is a dice is rolled once. Find the probability of getting a prime number, number lying between 2 and 6, and not an odd number. So let me first write what is sample space. Sample space will be 1, 2, 3, 4, 5, 6. So what is n of s? They are 6. So number of possible outcomes. Number of possible outcomes are 6. Now let us go to the first one. Probability of getting a prime number. So for this, what is sample space? The sample space is, say, a prime number from this. That is 2 is a prime number, 3 is a prime number, 5 is a prime number. So n of s is 3. So number of favorable outcomes are nothing but 3. Therefore, probability of getting this event is number of favorable outcomes by number of possible outcomes, that is 1 by 2 is the answer for this bit, children. Now, let me go to the second one. Second bit is a number lying between 2 and 6. So, what is its sample space? Sample space is number lying between 2 and 6 means 3, 4, 5. So n of s is equal to 3. Therefore, number of favorable outcomes is equal to 3. Therefore, probability of this event is nothing but 3 by 6. That means this is also 1 by 2 is the answer, children. This is second bit. And third bit, not an odd number. It is not an odd number. So, what is the sample space? Sample space here, see, in this not an odd number means I should take 2, 4, 6. 2, 4, 6. These are even numbers. The remaining 1, 3, 5 are odd numbers. So, n of s is equal to 3. So, number of favorable outcomes are 3. Therefore, probability of the event is again 3 by 6, that is 1 by 2. So, in all the cases, we got 1 by 2 only as the answer, children. So, let me explain once again. A dice is rolled once. Find the probability of getting a prime number, a number lying between 2 and 6, and not an odd number. So first let me write the possible outcomes. What is the sample space when a number is when a dice is rolled? All the 6 numbers. 1, 2, 3, 4, 5, 6. So total number of sample spaces are 6. So possible outcomes are 6. And a prime number. A prime number here 2, 3, 5 are prime numbers. So number of n of s is 3. So number of favorable outcomes are 3. So probability of getting a prime number is nothing but 3 by 6, that is 1 by 2. and the second one is a number lying between 2 and 6. That means what is its sample space? After 2, 3, 4, 5, we cannot go for 6. Again, here also n of s is 3. That is favorable outcomes are 3. So probability of getting a number lying between 2 and 6 is 1 by 2 only. Then the next one is not an odd number. It is not an odd number means sample space in this. It is not an odd number means I should take only even numbers. What are they? 2, 4, 6. Again they are 3. So again you are getting probability of not an odd number is 1 by 2. Please note it down, children. The eighth question, children. Eighth question is, what is the probability of getting a red king from the deck of cards? So number of cards in a deck of cards is equal to 52. So number of possible outcomes are 52. So we need to find out probability of getting a red king. Probability of getting a red king. For this, let us write the sample space. What is the sample space? You are going to have a diamond king which is red in color and also a heart king which is also red in color. So, what is n of s? N of s is 2. Therefore, number of favorable outcomes is equal to 2. Therefore, probability of this event is nothing but favorable outcomes by possible outcomes. 2 ones are, 2 twos are, 2 six are. 1 by 26 is the answer for this problem, children. Listen once again. The question is, what is the probability of getting a red king from a deck of cards? So number of cards in a deck of cards is 52 cards, 13 into 4. So number of possible outcomes will be 52. Now the question is probability of getting a red king. What is the sample space here? Red color cards are diamond and heart. Both of them are having kings. So diamond king and heart king. So total number of sample space is 2. That means favorable outcomes are 2. So probability of event is, that is probability of getting a red king is 2 by 52. That is 1 by 26 is the answer, children. So please note it down. Now, ninth problem, children. Make 5 more problems of this kind using dice, cards, or birthdays. And of course, they asked us to discuss with your friends and teachers for their solution. So, you need to make 5 problems. So, let us see. See, this I am doing just as an example, children. It's your wish. Whatever you wanted to do, you can do. So, first one I did, what is the probability of getting an even number when a dice is thrown once? Even number, what is the probability? Of course, how it has to be done, that is the number of possible outcomes. So, one by one, if you do, the solutions for the first one is sample space. Sample space is 1, 2, 3, 4, 5, 6. So, n of s is equal to 6. So, number of possible outcomes is equal to 6. And what is that one probability of getting even numbers? So, what is the sample space? Sample space for even numbers. Even numbers. So what is the sample space? You are getting 2, 4, 6. So n of s is equal to 3. So number of favorable outcomes is equal to 3. So what is P of E? P of E is 3 by 6, 1 by 2. This is the answer for the first bit what we have discussed, children. Now for the second bit, what is the probability of getting a spade from a deck of cards? So the possible outcomes, number of possible outcomes are 52 because n of s is 52. And what is that spade? A number of spade cards is 13. So number of favorable outcomes is 13. So what is probability of the event? 13 by 52, 1 by 13 by 52 will be as it is. We cannot divide it, children. It's not 42, 52. So 13 by 52 itself is the answer for this problem, children. Next, third bit. Third bit is, what is the probability of getting a card of green king? Green king does not exist. Green king does not exist. Therefore, number of favorable outcomes is equal to 0. Therefore, probability of event is also equal to 0. This is the answer for the third bit, children. Now, fourth bit. What is fourth bit I have written? Probability of getting same birthday when two friends is 0.08. What is the probability of not getting same birthday? So P of E is given as 0.08. P of E dash is equal to how much? We know that P of E plus P of E dash is equal to 1. So that means 0.08 plus P of E dash is equal to 1. So what is P of E dash? Is 1 minus 0.08. That is from 1, 0.08 if you subtract 0, 0 here, 2 here, 9 here. So 0.92, 0.92 is the answer. Next, fifth bit. A dice is thrown once. What is the probability of getting 7? So 7 does not exist. Therefore, number of favorable outcomes is equal to 0. Therefore, probability of event is also equal to 0. This is the answer. So, just you have to create 5 problems and find the solutions, children. So, what are the 5 problems that I have done? What is the probability of getting an even prime number? Even prime number means number of even prime number sample space is only 2, children. Even prime number sample space is 2. So this is n of s is 1 only. If n of s is 1, number of favorable outcomes also will be equal to 1. So what is the probability of event? It is nothing but 1 by 6. I thought it is even. I'm sorry, children. So number of first question is, what is probability of getting an even prime number when a dice is thrown once? So sample space is 1, 2, 3, 4, 5, 6, and n of s is 6. Number of possible outcomes are 6, and sample space here What is that? Even prime number. Even prime number is only 2. So n of s is 1. So number of possible outcomes is 1. So P of E is 1 by 6. I am sorry children, this problem, please note it down once again. Next, what is the probability of getting a spade from the deck of cards? Number of possible outcomes are 52 because there are 52 cards. Number of spade cards are 13. So number of favorable outcomes are 13. So P of E is 13 by 52. That is the answer. Third one, green king. You need to find what is the probability of getting a card of green king from a deck of cards. Green king does not exist. So number of favorable outcomes are 0. So P of E is also 0. And fourth bit, the probability of getting same birthday of two friends is 0.08. What is the probability of not getting same birthday? So probability of event is given. They are asking probability of not event. So we know that probability of event plus probability of not event is 1. So 0.08 plus probability of not event is 1. So what is probability of not event? 1 minus 0.08, that is 0.92. And fifth bit, probability of getting, a dice is thrown once. What is the probability of getting 7? So 7 does not exist. In this sample space, there is no 7. 7 does not exist. So number of favorable outcomes are 0. So probability of outcome is 0, children. So please note it down. With this, I'm going to conclude my topic today. In the next class, I'll be doing the next part.